Grading our homework. We're grading homework from last night. Last night was Monday, and that's March 30th of 2015. And what we're doing is instead of grading the papers, we're passing papers, and the person who gets the paper is going to be writing down whatever's missing. So, all of you, if you don't have a given of 14 grams of aluminum hydroxide, and you don't have an actual under the given, there's actually two givens and two finds. If they're not there, or if the given and find are not there at all, put them in. Because you should be doing all problems this way. Josh, could you please tell us, in the balanced equation, what two substances are we going to use for our mole ratio when we do our calculation? Yes, good. You're doing it. Good. Say it again. Aluminum hydroxide. Excellent. And what's the other one? By the way, the thing I'm thrilled about is he's actually naming them. The more we name these things, the easier the naming becomes, right? Okay. Excellent. Aluminum chloride. And that's the way I expect you to be doing your naming at first. Your mind kind of sorts through the things you need to be able to do, and it does it. So here's our ratio. And now let's go down and let's check the theoretical calculation. Notice I'm going to label it in all of the slides that we do today. I have on the little blind that I'm using the name of what we're doing behind it. I just kind of stumbled into that this morning. It seemed like a good idea. So Daniel, would you go ahead and give us what the first fraction has to be, or should be, or what you have on yours? What do you have on yours? No, the one you're grading. Come on, say the name. Yes, aluminum hydroxide over. Good. Okay, so we're always starting with the given over 1. And Aga, could you please give us what the next fraction is on your paper? Good. You're using the molar mass, and you have the molar mass on the bottom, so we'll cross out the aluminum hydroxide grams, and we've just converted to moles. Now we're going to use that magic mole ratio. So Vane, what's on your paper for the mole ratio in the next fraction? I'm sorry, I said Mane. Vahe. Read that wrong, didn't I? Okay, Vahe, what's on your paper? 22.0 over 1 mole OH. After this fraction? The next fraction? To the right of what you're seeing so far? Okay, dead wrong. Okay, this is your mole ratio. Okay? Now, the actual calculation would work out fine if you didn't have that first, but if you leave this mole ratio out and you get the right answer, you're just lucky because you had a 1-to-1 like we have here. And then if you leave this out, your calculation will come out all right. But if you're canceling units, and would you please cancel units with me now? I want you to get in the habit of doing this, please. I cross out the grams and I cross out the name of the substance or the formula of the substance. Okay, we're getting rid of grams of aluminum hydroxide. We're getting rid of moles of aluminum hydroxide. And now we have moles of aluminum chloride. Okay, and our next one goes to, now we're going to Vane. So, Vane, would you please tell us what your last fraction is on the paper you're grading? Is there a last fraction? Just sit it right there. What? That's fine. Don't worry about it. There you go. That's great. Thank you very much. Okay. What do we have, Bonnie? There's nothing there? Okay, then you need to fix that paper. What there should be there is this guy. Okay, we have 133 grams of aluminum chloride, which is the molar mass of aluminum chloride on the top, and the molar mass of aluminum, or I'm sorry, 1 mole of aluminum chloride on the bottom. And the answer you should have is something fairly close to this. And would you notice that I'm rounding all of my numbers now and will from now on? I'm going to always round to 3 sig figs. Okay? And let's go ahead and finish crossing out the units of measure. If your units of measure cross out and you have nothing left at the end except the unit of measure that was asked for, okay, the theoretical yield of aluminum chloride, it is aluminum chloride, so we got the right stuff. And probably in my theoretical there, I should have put the word grams because that's the way it's always going to be. Okay? So that's how you get that first kind of problem. And let's go on down now and look at the theoretical yield. And for calculating the theoretical yield, Yeva, would you tell us what you have? First of all, this is what you're doing, right? We did that in the do now today. And Yeva, what do you have on your paper? Yeva's no. Oh, can you read the numbers at all?
Yeah, I think it looks like a 22.009.
Yeah.
Oh no, that's grams. That's not a 9. Sorry.
Okay. Yeah, it's 22 grams over 23.
Yeah.
23.9.
Yeah.
That's what we ought to have. And does it look kind of like 92.1 for the yield?
Yep.
Okay, good. All right, so one down. And let's go on to the next one. And let's see if you are coming up with the right stuff here. Again, at the top, if you don't have the given and the find, the way you see it here, and I should probably be saying this yield in grams of silver. Theoretical yield in grams of silver, and we're given grams of copper. And our balanced equation looks like, well, the equation looks like this. I think you had to balance this one, didn't you?
No.
Didn't you have to balance? I think you did.
Oh, yeah.
Yeah. Yeah, this guy. The last one was balanced for you. Okay, so let's go to Christian. Christian, what do you have in your balanced equation for coefficients? What's coefficient for copper? Good. Okay, we're good there. How about silver nitrate? Good. And copper nitrate? And by the way, this is actually copper 2 nitrate is the way it should be named. Oh, no, yeah. Okay, it is copper 2 because there's 2 nitrates, and each nitrate has a 1 minus. So there's 2 negatives, so there has to be 2 positives, and there's only 1 copper to give it to us. And copper can be either a 1 plus or a 2 plus. Okay, and what's our last coefficient? Great. And Christian, what do you think the 2 substances are that we're going to use in this balanced, or to do the conversion and get us a mole ratio? Okay, and? Yeah, silver. Ag. Yeah, argon is Ar, by the way. Yeah. Okay, and that's the ratio you want to be working with. Okay, so let's go down and let's do the calculations. And for that, let's go to Arme on the paper you're grading. What do you have for the first fraction? It's not there. There's no calculation. Then you need to write it in. Okay, so start writing. Here you go. 22 grams of copper over 1. And folks, if people have stopped their calculation in the middle and and they strike a number, and then there's another calculation, and they get an answer, and then there's another, I just want you to cross those out and write it in the way you see it here. Okay, because this is the way I want it done. Bonnie, did you hear what I said? What's that in your hand? That a calculator? That a calculator? Yeah. Marisol, what do you have for a second fraction on yours? Good. And 63 point what? 55? Yeah. Okay. I rounded that to 63.6. And again, if you want to make your life a little bit nicer, I think it's best to go ahead and round everything to 3 sig figs. And that will work just fine. Yura, what do you have in the next fraction? This will be the mole ratio. Is Yura not here? Yura? 2 moles of silver over. Very good. Right out of this mole ratio that we established up here. Okay, so that's what we should look like. And then, Erica, what do you have on the next fraction? What? This is problem number 372, or page 372, number 28. What's the next fraction? Didn't do it, so you need to write that in. And the next fraction should look like this: 108 grams of silver over 1 mole of silver, which is, of course, the molar mass, right? Okay. And Sam, what do you have for an answer on yours? She's gone. Maya, what do you have for an answer? She's gone. Vanessa, I hope you're listening to the video, you two. Vanessa, what do you have? What? Hello, Vanessa. Welcome to the class. What do you have for an answer on this guy? Thank you. Okay, so 68 grams of silver, and this is our theoretical. Would you please write that in? Okay, write it in so the person whose paper you're grading will be reminded that that's what that number means. It's a theoretical. And you should also have written it in on the last problem. When we're canceling units of measure, we're checking ourselves to see if our calculation is valid. If the grams and the copper both don't cancel, then we've got a problem with the calculation. Let's get the rest of these guys canceled out. Would you please do this on the paper that you're grading? Okay, whoops. What should I have not crossed out? Grams of silver, yeah. Absolutely, I got carried away there. All right, so there's our answer, and let's do the percent yield. Okay, let's check that out. For time's sake, I'm not going to call on anybody on this one, but remember here, what? Yeah. Notice in this calculation, as the last one, notice again that the number on top is always smaller than the number on bottom, because the theoretical, which is on the bottom, will always be a larger number than the guy on the top. You come up with anything over 100%, you're upside down, okay, on that calculation. All right. This, I would like you to take a minute and copy down. This is already in your notes in miscellaneous. And so you should have everything but what the red arrow goes to. And you can, don't pass the papers back yet because we're not done with those. So would you please take a minute and write down the one that you see the red arrow pointing to, because you should have everything but that. this guy? All right, given and find. If they don't have it, the way it's, or as it's written here, or something that comes close to it, go ahead and fix it for them. And again, I'm going to put the grams in here because I didn't, grams of zinc chloride in this, or zinc iodide. Oh my, I've had this wrong all day. Okay, that's zinc iodide. And when you balance this guy, the coefficients worked out really nice. And that, of course, is your mole ratio that you're going to use to do your calculation. And you're usually in the third fraction. Okay, so Mary Beth, what do you have for the first fraction in the calculation for theoretical? You bet. 125 grams of zinc all over 1. Very good. And Selena, what do you have for the next fraction on your paper? Yep. Over, you have the 65.4? Okay, good. So that person's doing a good job. Michael, what do you have for the next fraction, which has to be the mole ratio? 1.912? No. It's 1 to 1. See, this is the mole ratio. And you use the coefficients in the balanced equation to get that mole ratio. And all you have to do is pop in the word mole. And you got it. Okay? And the last one is Ham. What do you have on your paper? Okay. By the way, that would be zinc iodide because it's not iodine when it's mixed with something else. It always has an IDE ending. Okay? And everybody in if you look up on the wall, folks, all of the halogens, all the guys in this column, they all end with IDE when they're mixed with something else. Okay? And that also makes them a salt. And your answer should be somewhere close to that. And would you please write in again the word Theo calculated to help the person whose paper you're checking get a good feel for how these different calculations relate to each other. And now you see we have the Theo. Theo is on the bottom, okay, as it should be. And then up top we have what was given by the word problem. And the numbers should come out somewhere around 84.5. Okay? And we are done. Okay, so that's it for what we're doing in the lesson today. Thank you for watching. I hope you find this helpful.